Hi and welcome to week 1 of the IET 320 Applied Statistical Quality Control class. This week is about quality basics. I'd like you to read textbook chapter 1 and 12. We are going to talk about the definition of quality and the complexity involved with that. We are going to differentiate between two philosophies for controlling quality, and we are going to talk about different types of quality cost. How would you define quality? Put yourself in the shoes of a consumer, and let's say you want to buy a car. What's important to you? How do you define quality? Things that may be important to you are things like price, maybe functionality. Will it start when you want it to start? How many options does it have? Do the seats come in leather and fabric? What's the gas mileage? And so on and so forth. Now put yourself in the shoes of the producer of the car. What things do you think are important to them? And how do they define quality? Different perspective. Let's talk about how some famous people have defined quality. Let's start with a professional organization, the American Society of Quality, which is the leading professional organization for quality in the world. They say quality is a subjective term for which each person has his or her own definition. Now think about that one. Let's say you're in charge of a quality department in a company, and you're responsible for your customers getting a quality product or service. And according to ASQ, quality is a subjective term for which each person has his or her own definition. That implies that each of your customers is going to have their own definition of quality. And then ASQ goes on in saying, in technical usage, quality can have two meanings. First, the characteristics of a product or service that bear on its ability to satisfy stated or implied needs, and a product or service free of deficiencies. Now, maybe a little scary to some people to be in charge of quality because, as ASQ says, it's a subjective term for which each person has his or her own definition. What does Deming say about quality? He says it's an error-free system. Durand says quality is fitness for use. And Crosby says it's conformance to requirement. But think about that. Could you have a product that conforms to requirements as stated and still not satisfy the customer? I personally like Dr. Feigenbaum's definition of quality. This has been my experience. Quality is a customer determination which is based on the customer's actual experience with the product or service, measured against his or her requirements, stated or unstated, conscious or merely sensed, technically operational or entirely subjective, always representing a moving target in a competitive market. I think that just about covers it. Now, since quality is kind of a grayish target to achieve, it depends on every person's own definition. It's not always stated. We have to really use all the tools we can to try and make sense out of what quality means to our customers, so we can make sure they get what they expect. What is the driving force behind quality? If you said customer, you were right. It's all about the customer. This course is about understanding statistical tools that empower the user to understand process behavior, so processes can be continuously improved and quality products and service can be delivered to the customers. This course will teach you tools that you can use to really truly understand your processes, so you can deliver quality goods and services to your customers. The tools that you learn apply really to any processes. It can be manufacturing, service processes. It can be a variety of industries. It can be the entertainment industry, hospitals, health, government, military, or manufacturing. Let's talk about what a process is. In its simplest terms, a process takes inputs, then you do some process steps, hopefully you do value-added process steps, and then you create outputs. Inputs is really anything that goes into a process, like raw materials, components, instructions, information, criteria. The process itself are the steps involved to do the process. And then the output can be tangible products, it can be a service, or it can be information. Let's take a look at an example. Let's say selecting a movie to see. We've all done that. Let's say we want to get together with a group of people and see a movie on Saturday evening. Inputs may be information like when are the show times and which movie am I going to go to. It could be information about who am I going with. It could be criteria for selecting a movie. For example, does it need to be rated PG-13? The process itself are the steps involved in going to the movies, like driving to the movies, buying the ticket, watching the movie. And then the output could be entertainment value of the movie. Here's some examples of processes in a manufacturing company. Financial management processes like paying bills or developing invoices or receiving payments. Any type of customer service processes like dealing with customer complaints or taking orders. Equipment maintenance processes. Any type of production processes that involve producing a part, for example, or inventory control. Process of hiring employees, process of training employees, process of firing employees. Usually there is step-by-step procedures that will define the process. So remember, in a process you have inputs, you have what goes into the process, you have outputs, what comes out of a process, and then you have the process itself, which are the step-by-step, the steps involved in getting the process done. I want to talk about a few terms, make sure we are on the same page when we talk about specifications and tolerance limits. Specifications are the goals that are defined typically by the customer. Specifications state product or service characteristics in terms of a desired target value or dimension. For example, a doctor's office may have a specification on how long it takes to see a patient, and the specification may be a person gets to see the doctor within 30 minutes. So the 30 minutes would be the specification. Now typically specifications are stated in terms of tolerances. You typically have a target value and then you have a tolerance or allowable variation around that target value. For our doctor's office example, the specification may be 30 minutes or less, so my tolerance would be 0 to 30 minutes. Or if I work for manufacturing companies and I produce a widget, and my tolerance for a thickness may be I want to have a thickness of 2 inches plus minus 1/1000th of an inch. So my target dimension is the 2 inches, my tolerance is the plus minus 1/1000th of an inch, which is a total of 2/1000ths of an inch. I have an example here about a list of specifications for operating a hotel. So this is a service example. On the left I have the item that was of importance to the company. Maybe they know that that's important to the customer, so they decided to develop some specifications about it, and on the right are the specifications. So for example, in the first row, what is the customer perception of service and quality? Our spec for that is 2 or fewer complaints per month. Next item, downtime of reservation or check-in computer. The specification is we don't want to exceed 15 minutes per month. The room reservations incorrect, overbooked. The specification is 1 or fewer occurrences per month. Why do you think the company went that far to develop specifications? Well, it's goals that you want to achieve. It's plan. If you have a plan, if you have a goal, chances are you're going to strive to achieve those goals. So you will collect data to see where you're at, and then you will compare those data to your goals. If you achieve them, you're happy, your customers are happy, and you may decide to do business as usual, or you may decide to improve on that even. If you don't meet your goals, you know you have to improve upon them.